Software-defined networks and its twin, network function virtualization, are the hottest of hot topics at the moment, even though there's no fixed definition of what they really are. So we've come here to Silicon Valley in California to find out a lot more. I'm talking with Rose Schooler, who is the Vice President of the Intel Architecture Group. Rose, thanks for giving us the time for the interview. Start at the very beginning. Can you define for us what, in your opinion or in your belief, is SDN and NFV?
Absolutely. SDN, simply stated from our perspective, and I think it's very consistent with the industry view, is the separation of the control plane and the data plane functions within the network device. By separating those functions, you have the ability from a central control point to manage that network asset from a global view versus a local view. Complementary, yet different, is network function virtualization, where you have the node in and of itself, which is typically a fixed function device that runs an application, and you take the application that exists on that node and create a software instantiation of it within a virtual machine on a common hardware platform.
Software-defined networking is a new, more open way of doing the networking that we're already doing. And what used to be integrated vertical systems with the control and the data plane all in a single system are now being broken apart so that there's a data layer that carries all the traffic and a separate control layer that controls how that traffic is routed and is done. That allows some new things. It allows different interfaces from the top, from applications, and it allows different ways of communicating to the hardware layer. And I think that's where some of those differences that you're talking about come in. What's included in the interfaces, what applications are going to be included, what the protocols are. Now, how does SDN relate to NFV, Network Function Virtualization? The Network Function Virtualization is similar in that it also wants to break apart the network functions. It wants to have a control layer and a hardware layer. The telecom operators would like to be able to address the network as an abstraction and not have to know what the piece parts are underneath it.
SDN itself was actually coined by an article out of MIT Tech Review, and it was actually in reference to OpenFlow. And the name was actually coined roughly off of software-defined radios, which is not at all accurate in terms of what the technique is, but it certainly borrows from that. And I think the thing that it borrows from it is, if you look at, so my background is I'm a programmer. And if you look at how you design software, there's a bunch of things in ways that people design software that they think is good. So you look for modularity, you look for loose coupling of things. And it's my belief that that's really what SDN is trying to do to the network. So if you look at the network right now, there's actually tight coupling and there's no modularity. If you buy a box from a given vendor, you get all of the things that come with that box, including all the features, and you can't mix and match these features across vendors. And so at a high level, I think those are the things that people are looking for when they want SDN, is the properties they want out of a software model, which is loose coupling and modularity.
Software-defined networking is an important new model for the way networking will be done in the future. It's really transforming traditional networking using distributed protocols to a centralized approach. For us, for NEC, the clear advantage of centralizing the control of a network means that we no longer have to rely on distributed protocols and the complexity associated with that in order to drive new delivery of services.
SDN and NFV is really kind of taking a paradigm that's existed in the server world for many, many years, but is now evolved much more from the virtualization perspective. Bringing virtualization technology has completely unfettered the server world. You have a very fluid environment, a very malleable environment where applications are brought up and brought down, moved from here to there, all over the place. And that has created a much more dynamic cloud environment. And what we'd like to do is take that paradigm and move it to the networking world, where now the networking workloads can be similarly moved and changed and replicated on a much more kind of horizontal, malleable architecture.
I believe that SDNs are part of a larger tree, if you will, programmable networks. We see that software-defined networks come in two classes. The one that most people talk about, where there's a separated control plane from the data plane. The other type are applications asking networks, APIs, for capabilities, for information or capabilities. So that's SDNs. Another part of programmable networks are just APIs to networks. That's the big picture for us for SDNs and programmable networks.